Saxon Algebra 1, lesson 118. You guys, this is one of my favorites. It's a gem. It is something that John and I want to put into your brain here at the end of the year. It's going to be a little confusing and overwhelming, but here's the thing. Just get through it as best you can, and the next fall when we come back to this, it's going to make a lot more sense, and you're going to go, oh, okay, it feels better in my brain. Okay. Let me just give you a little bit of context. It's called completing the square. And this is what we do when we want to solve a quadratic. And it can be equation or expression. And I'm pausing because technically you don't solve an expression, you only solve an equation. You can simplify an expression, but you can't solve an expression. And so this is a mathematically imprecise sentence, but I don't want to make it more complicated because you get the idea. Okay, what we have been doing so far is we have been doing it by inspection. We look at it and we go, oh, what are the two numbers that multiply to the last number and add to the middle number? And then we did a little advanced spin on that, and we said, okay, well, sometimes you have to multiply the first number times the last number, then find two numbers that multiply to that and add to the middle. But that we've done all of that just by looking at it and thinking, haven't we? We haven't done a calculation to find those numbers. Not really. We're just looking at it and finding patterns. We're going to learn two more ways that work for every single kind of quadratic, because this one only works for straightforward, relatively simple numbers. So this one works sometimes. And again, it's all dependent on the way the problem was set up, whether the numbers are going to come out even or not. But the nice thing about these next two is they work all the time. So this one is called completing the square. It's the second way we're going to learn to simplify / solve. I'm just going to write that here. My math brain is screaming at my basic brain and saying, you cannot leave it like that. By completing the square. That's the procedure we're going to learn today. But what happened is that way back in the day, after mathematicians figured this out, they said, man, that is a long and annoying process, and we don't want to do it every time. We would like something simpler. And so what they did was they took what they knew about completing the square and they mashed it all down to create a formula. And we call that the quadratic formula. And I'm going to introduce you to that in either 119 or 120. In 119, I'm going to teach you how to use the quadratic formula. That's a little less mind-bendy than completing the square, but both of these are ideas that we are introducing so that next year you'll have a little glimmer of familiarity when we introduce them. These two both work all the time. So the good news is you don't have to look at your equation / expression and go, gee, I wonder if it's going to work out like we do for inspection. These two work all the time. That's good news. All right. This is a very long process with lots of steps. And again, I want to tell you, this is lesson 118. And this we're going to see next time, 119. Okay, we've been doing this a lot this year. We'll come back to all three of them next year with a heavy emphasis on 2 and 3. Okay, here we go. Lots of steps to write out. Example 118.1. Solve x squared plus 6 equals minus 10x by completing the square. Well, as you write it down, you think, John, what's this mess? First thing we need to do is clean this up. We want to bring this back over to this side. That'll make this negative into a positive. When we change sides, we change signs. Now it's all set up equal to 0. So this, remember, we call standard form. So here are my steps. Okay, we call this standard form. Remember that we can also write it as ax squared plus bx plus c. That is standard form. Okay, and I want you to write it here because I want to be able to refer to the numbers as the a and the b and the c. All right, we'll do that more and more. You'll get used to it. The second thing we're going to do is we're going to kick c to the curb. Now you're wondering, why do I say it like that? Next year we'll do a certain type of problem and then you'll understand. Oh, and I'll tell you, that's why I said kick it to the curb. But we're gonna move it back to the other side. So now I'm not moving this one, I'm moving this one, right? This is our C value. So now I've got x squared plus 10x, and then I've kicked C to the curb. He changes sides, so he changes signs. He becomes minus 6. Don't let that minus sign freak you out, it's fine. And notice there's a gap here. We like that. So I'm gonna remind myself here, leave a gap. The reason why I want to leave the gap is because we're gonna create a number to put in here that's gonna make all of this turn out perfectly. And that is called the magic number. I know, that's my language, not John's. We're gonna calculate the magic number for this problem. After I calculate it, I'll show you why it's the magic number, why I call it that, and what magical thing that it does for us. Okay, how do we calculate the magic number? We take b, oh, I forgot the x here, right, 10x. Okay, the magic number, we take whatever number is in the b spot, the b spot. The b is by the x. So in our case, it's 10. We divide that number by 2, and then we square it. That's how we calculate the magic number. I also want you to draw an arrow to what's inside the parentheses, because that's going to become important. In our case, our b value is 10. We divide it always by 2 and always square it. So this number is 5. 5 squared is 25. So we would say our magic number equals 25. What do we do with our magic number? We add it into that gap, and then I'm going down for this because I don't have room to go sideways. We add it to the other side because we need it to balance, right? We need to, if we're going to add it to one side, we have to add it to the other. What we have done is we have created on this side a quadratic that's a perfect square. In other words, it's two binomials that are the same times themselves, right? So let's look at what that is. It means we can rewrite it like this. This is called a perfect square. And we know that it's going to start with an x, and then there's going to be a number that goes in the other half of this binomial, and those two numbers will multiply to this and add to this. Where do we find those numbers? Right here. Remember how I drew my arrow? I'll draw one here too. It's the number inside of the parentheses. That's what goes here. Sometimes it'll be positive, sometimes it'll be negative. This number will always be positive. This could be positive or negative. All right? That's a perfect square because it's the same thing times itself. Let's check. 5 times 5 is 25. 5 plus 5 is 10. Okay, beautiful. We did that right. Now, we want to collapse this. I don't know if you've ever seen those cups that are meant for camping. It looks like just a little round disc about that big around and about that thick, but it's actually a cap that comes off, and then a cup telescopes down so that it creates like a V-shaped cup. We used to have one, it was pink, it was so satisfying. Those collapsing cups, that's what I always think of. We want to collapse this like one of those cups and just write the binomial once, and then we'll put the square up there. This and this mean the same thing. This is easier to understand how we got it. This is in better working order for our next step, okay? So in the beginning, I'm gonna always have you write this, the full binomial square, and then reduce it to one binomial squared, because I want to make sure you follow that flow. Later, when you're really in the thick of this, you'll be able to jump from here to here. Okay, what about our little right side? This would be, what, 19, right? That's just a number. That's just kind of the dregs. That's why we kicked C to the curb, because we wanted a more perfect number here. So we kick him out so we can put the perfect number in, and then he's just chilling on the other side, balancing out with whatever it was we added. Okay, that's good. Now, I'm going to go to the top of the next page. Oh, yes, this way. We have x plus 5 quantity squared equals 19. And we're on step number 4. And I'm going to take I'm going to use a minimal amount of words. What we want to do is we want to solve this, right? We need to get this x by itself. It's being squared. How do we counteract a square? It's like a curse, isn't it? We need I'm thinking of Harry Potter. We need a spell to counteract that curse, and here it is. Square root, both sides. Beautiful, right? This counteracts this, and now we just have x plus 5 on this side. Over here, we've got square root of 19, but we want to recognize that we have two roots of 19, the positive and the negative. And that's really important that we remember to always include this little notation in here as we're solving these problems. Super easy to forget. Okay, and now we're just going to go ahead and solve. We can subtract 5 from both sides. And what we get for our answer is that x equals minus 5 plus or minus the square root of 19. That is the value that will make our original quadratic equation way back here come true. It's hard to believe that we need such a weird, awkward number to make such a simple quadratic come true. But that's the magic of completing the square, is that we can find a very precise answer no matter what numbers we start with. That's its gift to the world. Okay, if that was confusing, let's do it again. I want to start with a fresh page. Are we doing 2 of these or 3? We're doing 3. 118.2. Okay. John explains this a little bit differently than me. Excuse me. Similarly, but not exactly the same. Complete the square to solve. X squared plus 3 equals minus 5x. Okay, number 1, we get it in standard form. X squared minus 5x plus 3 equals 0. When we change sides, we change signs, so this positive becomes negative. Now we kick C to the curve. X squared minus 5x equals negative 3. We leave the gap, we change sides, we change signs. Now we find our magic number. This is how I write it. I take my b value, minus 5, I divide it by 2 because that's the way that little formula works, right? Don't have to think about that. I draw an arrow to what's inside the parentheses and I square it. I'm going to write the formula again just so that you have that right in front of you. Right? And so the number that I'm going to fill in, I'm looking to this side now, is positive 25 over 4. I square both of those. That's my magic number. I add it here. Now that's a creepy magic number, isn't it? But it's okay. I add it to both sides. This is like a little sidebar. I'm going to work around this. All right, now I want to write this as a perfect square. And I know that the arrow will point me in the right direction. It's x minus 5 over 2 times x minus 5 over 2. That's my perfect square. Let's check it. These two together are positive 25 over 4, and look, they match. If I add them, I would get, let's see, I'm in the ladder in the meadow, right? I'm at negative 5 halves, and I go down another 5 halves. The denominators match, so I can just add these. It would be negative 10 over 2. And negative 10 over 2 equals negative 5. And that's the B value. Okay, so it works. It should always work like that. Now I want to use my collapsing cup. Little did I know that someday I would want that collapsing cup to teach algebra. It was so satisfying. It was like a nice hard plastic, and my kids would use it in the bathroom, like for getting their drinks of water when they were little. And I don't know what happened to it, but it's not here anymore. Equals, now we're ready to deal with what's going on over here. Now we have to add together these two numbers, that's fine, but we need a denominator to match. So we're gonna multiply this by 4 over 4, so this will be negative 12 over 4. Negative 12 plus 25 is negative 13 over 4. No. Yes, that's right. I was looking at the wrong problem. This is correct. Now we're down to our last little series of steps here, which are, most people think, the easiest. We're going to take the square root of both sides. Wait, this is positive 13. There we go. That was my drama. Okay, positive 13 over 4. This becomes x minus 5 over 2, right? Without any squaring or square root drama. This, we'll put the positive negative first. We always want to remember that. Now, notice that the bottom is a perfect square. Right? What we can do is leave the top inside of its pig house, but pull the bottom pigs out. Make sense? And for our last step, we're going to subtract the 5 over 2. I'm not going to show that as a separate step. I'm going to use my change sides, change signs rule, and I'll have positive 5 halves plus or minus the square root of 13 over 2. Now I want to point out, that's our answer. Just a second, I'm double checking this minus sign because it looks like somehow I got it crossed. Oh, it's all the way back at the beginning. Okay, look what I did. I copied the problem wrong. Story of my life. That should be a minus. So this should be a plus. This should be a plus. When we did our magic number calculation, that should be a plus. This would still be positive 25 over 4. That's correct. But then when we went and did this number should be a positive, right? Because look, my arrow is pointing to a positive. This should be a positive. This should be a positive. Okay? Then when I change sides, change signs down here at the bottom, this becomes a negative. There we go. So I dropped the minus sign up here, but I can follow all the way through and just fix it. It doesn't change my magic number calculation because that is squared. So when I mistakenly had a minus sign there, it still squared out to a positive. So yay, it didn't affect any of that. And it just came all the way down to right here. This is the final answer. It should be minus in the answer. All right. That is a good example of how you can learn from your mistakes. And they're not necessarily the end of the world, right? Again, a simple little dropped minus sign up here, we can trace it all the way through the whole problem and fix it quite easily. All right, let's do the last problem. We're just rehearsing these steps again and again. Complete the square to solve. X squared plus 1 equals 3x. I'm going to bring this over. X squared minus 3x plus 1 equals 0. I'm going to find my magic number. I'll calculate it over here this time. I have a little more room. Remember, it's b divided by 2 squared with an arrow right there. In this case, it is minus 3 over 2 squared. Okay. Oh, I didn't kick him to the curb yet. Sorry. There. That's better. The reason why I caught myself is because I went to write the magic number and I'm like, where's my gap? Oh yeah, I didn't create it yet. I forgot to kick him to the curb. So that's one thing to remember about these is once you get the flow of it, you can catch your little mistakes as you flow along. Each step is designed to catch itself. Do you know what I'm saying? Without the gap, I didn't have anywhere to write my magic number, and that reminded me, oh, look, I need to kick him to the curb. Okay, so now I'm ready to add the square of this, so that's 9 over 4. That's my magic number, right? Here, I'll write it up here. Magic number equals 9 over 4. All right, and I have to do it to both sides. Okay, I'm gonna write my perfect square first. I like to clean up this side first, and then I'll come back and do that. X, and it's the number inside, so it's minus 3 over 2. Don't let these fractions scare you. They don't really hurt us. When the magic number comes out to be creepy like that, oh, look what I did. I wrote the wrong number. No, this is right. This is right. I'll tell you why. Because when we write the binomial, we're using this number. That's what the arrow tells us. So then I can rewrite this as x minus 3 over 2 squared equals, now we'll deal with this mess. I need the denominator to be 4. Well, I can easily change that to 4 over 4, right? So this becomes positive 5 over 4. Great. Now I take the square root of both sides, and I get x minus 3 over 2 equals plus or minus. Notice what happens. Our denominator will go to just plain 2. It always works out that way. The bottom is a perfect square because we got it from this perfect square calculation. The top is a bit of a mess, but that's okay. All right? And our last step is to swim this across, so we get x equals 3 over 2 plus or minus the square root of 5 over 2. And this is the right answer. Now, I just want to say one more thing about the shape of this answer. This is the way I want it. Sometimes students go, oh, but look, the denominators match. So we could do 3 plus or minus square root of 5 over 2. We could make it one fraction. No, don't do this. I'll explain why later. But later there's going to be a situation where it would be completely wrong to do that. We want them to be separate. So we're going to instill the right habits now. Always show them as separate fractions. Do not squish them together, even though it would be mathematically okay to do it here. We want to keep it like this. This will be on the test. Again, I know it's a lot to learn at the end of the year, but you will be so happy when next year in Saxon Algebra 2, this is going to show up around lesson 40-ish. And then you'll be like, oh, I remember. All right? So we're going to come back to this and practice some more, but for now, you know enough about completing the square to be dangerous. Thank you. Goodbye.